Now in this video I'm going to show you the short circuit test. One second. And what do we measure? What do we measure and what do we calculate with the short circuit test? Now I did the no load test in my previous video, transformer 6, no load test, electric machinery. This is transformer 7, short circuit test, electric machinery. And first, now let me show you the wiring diagram for the short circuit test. Let me just do it, and it's gonna be easier. It's gonna be easier to show you and explain to you with the diagram. Now we have one phase supply, right here. We have an ammeter, same as the open circuit test. But as the name tells you, the secondary now, or the low voltage side, is short circuited. Now, in this test, looking at this practical transformer equivalent circuit, I got to tell you that the exciting current is 5% or less of the primary current. So in this short circuit test, we remove this middle shunt branch. Because the exciting current is neglected in relationship with the primary current, and in this test we don't have a load, so here the circuit is shorted. Now we can calculate with all this ammeter, wattmeter, voltmeter, what are the values of R1 in series with R2 prime, and then we can calculate the series reactance of XL1 and XL2 prime. So R1 and R2 prime is the equivalent resistance on the high voltage side. In this test, the high voltage side is measured with ammeter, wattmeter, voltmeter, and the low voltage side is measured with is short circuited. So this here is the high voltage side, and this is the equivalent reactance of the high voltage side, and the complex value of this is Z equivalent. Now this is here R equivalent H plus J, the imaginary number X A equivalent H is equal to the impedance of the high voltage side. And this is the equivalent circuit for the short circuit test. And how do we calculate all this? Well, with wattmeter we can measure what are the active power losses, and active power losses go on the R equivalent, the series resistance, the R equivalent of the high voltage, and that is equal to the power that shows the wattmeter divided by the current squared. The impedance is equal to V1 divided by I1 from the apparent power. So this is for alternating current, and series reactance is equal with Z equivalent H squared minus R equivalent H squared, all that on 1/2. So the square root of Z equivalent H minus R equivalent H, that's from the Pythagoras theorem. And yeah, that's what we can calculate. And in a good transformer, good transformer, R1 is equal to R2 prime and XL1 is equal to XL2 prime. If the transformer is well designed, this R1 is equal to R2 prime and XL1 is equal to XL2 prime. You know that A is squared, but you know, in a well-designed transformer, this is you always want this to be equal. So, so that was the short circuit test. We can calculate what is the resistance and the transferred resistance of the low voltage side, and we can measure the reactances of the flux leakages in the transformers. So thank you for watching, and in my next video I'm gonna show you example for the no load and short circuit test, and maybe it will be easier for you. So in my next video it's an example with the no load and the short circuit test. And have a nice day. See you in my next video.